Hi everyone, this is Byte Relay, and today we are talking with Stas Kirwich, co-founder of Neon Database and Postgres hacker and expert in database systems and distributed databases. Hi Stas.
Hey, Andre. I'm a co-founder at Neon, and for the last 10-ish years, I was working with the Postgres community as an individual contributor, as working full-time at a company called Postgres Pro, where we supported fork of Postgres, and I was mostly working on high available setups, on transactions, distributed transactions, and replication. So that was my area of responsibilities there. Then I was working there for like 5 years, and I also had a chance to work for a year and a half. Oh no, actually about a year at Yandex, working at Yandex database, which was a fun experience. Lots of data. So Yandex database had several clusters deployed inside of Yandex with a total amount of data around 100 petabytes by like during the time I was working there, which is an interesting experience. You have some like software, hardware failures, interesting experience in managing big fleets of nodes, and now about a year and a half ago, I've founded Zini. So I've met Nikita, I've met Heikki, it's two other co-founders. And yeah, we basically original idea was let's create open source version of Amazon Aurora, and to the large extent, it's the same technical idea, but we changed messaging a bit. So now we call it serverless Postgres, which a bit more bit more marketing-ish, but I think it's people get it a bit better because with positioning just as alternative to AWS Aurora, we confusing people who don't know what what Aurora is, and there are a lot of them actually. So in database community, we tend to know what it is, but like wider developer community sometimes just I heard but never understand what it is. So yeah, we are positioning ourselves as a serverless Postgres mostly, and like going to a bit more technical details, we do separation of storage and compute, and that allows us to independently scale for storage and compute. That sounds like a good cloud, good way to run database in the cloud.
Sounds very interesting, and I personally believe that this new fascinating technology will change the database landscape a lot. Like we depended on local disks for decades, and now finally we are separated from disks, and this is a database not on disk. Sounds great, but
just to put in some historical perspective, I think it's like back and forth a lot. So there's a reincarnation of this idea with that disk arrays.
Yes,
in
back
hardware,
and forth, but not that distant. Like
separate,
completely separated.
So it seems that it was disk arrays was really popular ideas, and everybody thought that like running on a commodity hardware is a better idea. But then when you run this on scale, you need to also understand that okay, now I probably need a specialized node. So just in terms of cost efficiency, you will have some nodes with a lot of disk and some nodes with almost no disk and CPU. Like okay, now probably I need to reflect that in my architecture, which will remind again this disk arrays architecture. But sorry for interrupting you.
So this is the next cycle of development spiral. Anyway, it sounds great for developers. But let's get back in time. Why did you started to learn databases? Why are you interested in database? How comes that you?
I actually came from a physics background, so in my I was always hacking on the software, like starting from school. I think the first language was ActionScript, with a Flash. It was still Macromedia Flash the days. And just skipping through all of that. I had a small startup which and that was a like product company. We were writing package tour search engine. And package tour search engine means that you have several service providers that provide a lot of like usually XML, like the days XML data about package tours, and package tours is like hotel and dates and prices, and you have a lot of these categories, and you need to parse all of that. It would be like about 10 billions of tours active like at this country at this moment, and you need to quickly search through them. So and you also have few parameters that user is provided by the user, so like range of dates, range of prices, and that's kind of interesting search problem. So I tried to use Postgres for that with usual indices. It didn't work out. Then I learned a bit about multidimensional indices like R3, which usually used for geography, but I was curious, can I use it for like integer data types, just to have like several ranges? And that's actually how I started hacking on Postgres. So like I just went to the bookshop, bought a book about C language, read it, like that's a classical Kernighan book, and then
learn C in 30 days and something like that.
Well, I think you can learn C in a few days. Like you don't need like see the simple language. See the simple language.
No doubts, just 48 hours and you are a C programmer.
And just doing a bit of off topic. I saw interesting non-standard interview problems where you just handed over a code base, and like you may know this language, you may not know this language, but you need to actually implement a like simple task. And the point of this interview is actually understand how can you navigate through the lot of code, and there are common patterns like how can you do that. Yeah, but going back, yeah, we used R3. I hacked a bit with R3, sent few patches to the Postgres community. I think like storing, like improving amount of data is stored on disk. Like in certain situations, Postgres was storing multi-dimensional points 2 times, and it was necessary, so I implemented the flag, and it like decreased in some cases number of bytes stored like 2 times, and that's how I started working. That
So
I wrote.
To put it basically, you just hacked on Postgres because you needed features that didn't exist at the time.
Yeah, and I tried to improve some features that existed there, because yeah, I mean, I think it was just, yeah, we were talking about a decade ago, but like database for us was about terabyte, which was big, and I just had smaller.
It's still big. Terabyte is kind of a chunk of bytes.
And I just had a smaller. Maybe it wouldn't be a problem at all, but because it's a tree, and if it's well balanced tree, you still kind of it will do the job. But I had just smaller HDD, and with this patch, I was able to fit it on my HDD, and that's
cool. So hardware restrictions made you hack on Postgres, like that.
Kind of, and I think it's just interesting. So that's
and
I can face a lot of problems in my life that I can solve, but I try to avoid solving all of them. But with exactly that one, it was just interesting to hack on.
And right now, your company is working to solve hardware restrictions.
Well, you can put it that way.
So you started with this, and you are still doing this, solving hardware restrictions.
Okay, yeah, okay.
Sounds great. Okay, if you are doing like state-of-the-art database, you need to constantly learn something new. How do you do this? How do you learn new things? How do you get to know new technologies? So do you read newspapers, like scientific papers?
So it depends on the topic, but generally I'm naturally curious. I like to hack and experiment with with a small new things, and I try to find time for that. But it's easy because I like doing small experiments. If there is a new service, if there is a new technology, just like spend a few hours playing with it. Mostly with the marketing pages, it's not you're not getting the idea of what it is, but then when you play with it, you can find it like place on the map for this service or thing. But sometimes it's just you need to make up a time if you know that there is some big amount of knowledge that you are missing. You just need to make a time and try to do it.
Just buy a book on C language and read through.
Yeah, I mean, book on C language is, I would say, it is a simple example because it doesn't make too much time, and I'm not saying
it's absolutely
about
insane. C in not too much time.
Again, like
superhuman abilities.
Probably we just have a different definition of done on that one. I'm by the no way C expert. So if I'm seeing like C quizzes about like what kind of undefined behavior that code will produce, and yeah, that's definitely not my strongest thing. But like, I mean, C and Pascal, I think it's still fair to say that the straightforward languages to use. You need to make your head around pointers, and that's probably the only obstacle. Now, if we are talking about C++, it's just a way bigger landscape, and you probably need to spend more time to get fluent there. So yeah, I don't think like learning a single, like just to be able to hack on a new code base, if you know like JavaScript, it's the same curly brackets. You basically need to know a bit more. What?
Most difficult stuff in curly braces, yeah, it's.
Yeah. I mean, you basically can read the code. You just need to make your head around pointers and memory allocation. But that's, I think, with some amount of explanation, if you have somebody to ask for it, it's straightforward. What I'm actually think a bit more complicated is when you need to understand something, some like big topic. For example, I mentioned R trees, and again, I came from a physics background, so I actually needed to learn a lot about data structures, and that is way more longer process. So then you actually buying a book, but it's not that a book readable in a few days, and you need to just slowly go through it, like probably half a year if you are doing it over the like
So
weekends.
Half a year, probably you need to do a lot of books in parallel. How many books do
I actually don't
the
do
hacker?
I actually don't do that. So the way I did it, I actually Googled internet on what books on data structures are there. I picked one of them. I think there is a blog article from Dan Liu on which one he found interesting. So I picked one, and just I was reading it about a year, I think. So I was reading a chapter, doing some of the problems. So, and I mean, and not that I was doing it full time. It was like, I would say, mostly like main hacking project.
Can you share a link on this learning resource so we can recommend it to our viewers?
Yeah, it's a Skiana book. It's a Skiana book, and the name there is algorithm something. I don't remember exactly.
I will find it and put under the video.
And not that I too recommend it. I think now there are better books.
Which one would you recommend? Recommend one source for learning. What would you recommend?
For learning algorithms.
Anything. Just
I would
anything.
drive people actually towards the same Dan Liu blog post, and I will attach link, and he has some overview of different books, so you can actually pick one that you think will fit you most.
Very good.
So that was a big project. Then when I was working on a Postgres Pro, we were working on a high availability project, and we coded it actually another person, Konstantin Knizhny, coded it in a very quickly manner. But then we tried to fix bugs or problems with a setup for high availability, and we just understood that it's not going to converge. We are fixing some problems and new one appear. So then during that time, I was making a lot of time actually to go through books on distributed systems. Again, was a new topic for me. So I ended up learning some TLA, writing a Jupyter kernel for TLA to hack with it, because to play with it, because I didn't like usual TLA GUI. So I think that's heavyweight Java graphical interface. So I wrote Jupyter kernel for that. So I played a bit with the TLA. I tried several books on the topic, and there are good books on that. Again, I can leave some links, but with distributed system, I think starting with the right papers is a better way to go. And right now, I think there is also one book that is about to be released on a distributed system. I probably would say that it's right now it would be the best one. But it was I started 5 years ago, and there were only, I would say, 2 academical books by French authors. So Cashin, I think Cashin, Reliable and Secure Distributed Systems. That one was useful, and just going through the papers, Lampard papers and so on, helped me a lot. And that, again, it was I would say I was spending about a year on that. What else? I think meanwhile it was some amount of learning on transactions, and that was weird because I think there is a lot of research about transaction isolation levels, and if you try to go deeper there, it's hundreds of isolation levels, and there are really big papers written on that topic. But I think it's still to shift it to a research, so that actually a lot of that is mostly interested for the researchers, but not for practical purposes. And for practical purposes, if we are talking about snapshot isolation, snapshot stability is the most important thing, and all the other. So basically, you can invent your own isolation levels if you're just creative enough. And for researcher, it makes sense because you will have your named problem. But in a practical sense, whatever, you only need interested in that in the phenomena arising from some optimization.
Database developers, application developers, already think that databases are too complicated to grasp. And you just want to build a web service, or you just want to build an app, but you have to deal with models of consistency, models of failure, and distributed systems. And will we have a simpler database? It just works and solves the problem.
Well, I think yes, it's more for I think efficiency question, so that we totally can and we actually have for example like Google Firebase. It has HTTP interface. You can talk with it from front end. It handles some amount of auth for you, and it doesn't have anything complicated there. I mean, it just works. The service just works. It scales. But now at some point in time you will have to pay for this service, and now it turns out that you can do a lot better if you actually start thinking of stuff like concurrency, and maybe you need to think about isolation depending actually on the app. Maybe you need to think about this isolation levels, maybe you're not, but just densely packing it together, you can pack a lot in a single like classical database service server. You can have like billions of transactions from one server.
So to rephrase that, if developer want to make efficient and highly loaded system, they will still need to learn a lot about how databases works, and this invariant won't change.
I think it's inevitable. Yeah, if you have like few millions of transactions, you will either, so it's maybe you now you don't need to learn it yourself. So if you have millions of transactions per second from somewhere, and you are paying for them for some service to handle it, you're paying a lot of money. So now you actually have some amount of money to hire somebody who understands about these problems, and probably so I think like just in terms of efficiency, it just shifted to the fact that let's hire somebody, and this person will.
This looks like a problem of isolation. So we can't isolate knowledge about databases from knowledge about the system, knowledge about application. They interleave, and still architects and developers will have to learn a lot about databases, even in maybe 10 years or 30 years. Maybe at some point we will solve the database problem.
Well,
someday.
I think that's like this question about 42. So what?
Okay, 42 years. I'm starting my timer.
No. I'm just like an answer on a question of life and earth and everything like that. I mean, what's the question? Like, what's the database problem? So you're suggesting to solve the database problem, and how quick we can do it. But what's the problem in the first place?
Today, developer want to write a simple application in a programming language they know.
Yeah, and they do that.
And they do that, but they have to know SQL. They have to know.
They don't. Like why? Like average. I think average JavaScript programmer doesn't know it, and it's totally fine.
So the database is a solved problem. It's the problem of money. Just pay more for service.
But again, what's the problem? If you're saying the problem that somebody needs to know SQL to save data, I think you can get away with JSON, and there are a lot of nice services to solve that for you.
So modern developer cannot avoid knowledge of SQL, or can?
I think modern developer totally can avoid it and write great apps without SQL, without knowing SQL. And there are a lot of people that don't know SQL.
Will we have SQL for a long time?
Probably I think we will.
At some point,
I think we will. I don't think it's contradictory topics. We still have COBOL running a lot of financial systems. We will have SQL, and I mean SQL.
Developers don't need SQL. We will have to learn SQL. We are not developers.
All the developers don't need SQL.
Not every developer needs SQL.
Right? You can write a good app without knowing
most
SQL.
Developers don't need SQL. Half of the developers.
I'm not sure. But that's again a question of if we are looking at the world of developers, I'm not sure what the median developer is doing. Is it? I guess it's web development, but I'm not sure. Like maybe there are more. I don't know. Like this
For Chrome developers.
ABAP
Yeah.
developers, or like somebody is writing something for SharePoint. I'm just not sure. Kind of my guess would be that it's the web developers with a classical open source stack, but I'm not extremely sure about it. If we are talking about modern web development, yeah, you can take some JavaScript framework, deploy like let's say, for example, Next.js. You just need to push it on a GitHub, press a few buttons, deploy it to yourself, which will deploy it to serverless functions, and voila, you have it running. Now the question is where you store your data, and there are a few answers to that. You can use a SQL, you can avoid using SQL, and that's again depending on the app. If you're building something simple, like take something simple, just like Google Firebase. If you need something more complicated, and by more complicated, I mean you need to actually have some analytical functionality, or you need something like geography. And there are a lot of reasons that you will end up with SQL, and SQL delivers some amount of fair amount of value. And yeah, I mean that then actually you can use SQL based database, which is I think fine.
Yeah, just a broader spectrum of functionality with SQLs and with
but like going back to your question, what's the database? So what's the database problem in your definition?
We need some subsystem to store data and retrieve data, and we have to understand how it works, and we can't learn it in 48 hours or so.
I think what you are talking about is like general leakage of abstraction. So on some level of functionality and performance, you can totally ignore how the subsystem is working, whatever it is, database, your car. I mean, you can think of like human, some social institution. I mean, it just works. But when you're starting to put it to the limit, or you use less popular functionality, then yeah, I mean, you need to know how it's built inside, how it is working inside.
Okay, so efficient hacking is forever.
Yeah, I don't think that like it's generally solvable. I mean, we can try to move that like goalpost here, so that like you can have broader spectrum of problems solved without you getting into internals. That I think that is a great goal, so that the more and more load you can take and queries you can serve without person actually trying to look inside, the better. But it always like would be some breakage point after which you need to go inside. So maybe you were talking about that it's just with the current databases, it's this limit is too low, so that you need to go in.
Typical things that you have to understand in modern databases, that you need to separate analytical database from operational database. Will we break this wall someday? Do you believe in hybrid database systems, or will we have two different systems forever?
Okay. So so I think it actually goes back to the Stonebreaker. Like a few decades ago, he had this presentation about that. We need to.
What comes around, what goes around? Do you refer to that paper?
I don't remember what was the name, but he defined three areas, namely OLTP, analytics, and scientific data. As have a bit like different constraints on the databases, and Stonebreaker went and built 3 companies. Each like with one database company per that segment. So that was VaultDB, it was it Vertica, and third one was SciDB. Yeah, I mean that's so reasonably you can do better if you narrow down scope of the problem. Can we build one unified system that will be good at all of these loads? I think the answer depends on what we will see with the hardware. So if our hardware is stable for long enough, so like if there is not that much advancement in a hardware side, and we are actually more or less stable for the last like 15 years, like CPU frequency is not that much increasing. We are seeing more cores, but I think it's more or less the same range. We at the same time we saw a lot of improvements on disk on the storage side. So SSDs changed a lot. Yeah, so if we are living in a like stable world of hardware, I think it's probably possible to write a system that will just fit it all. But whenever you are living in a changing world of hardware and generally changing world, if you're having a narrow scope
in
of
real
problem,
world, I'd say.
yeah.
Not
if you
an
have
ideal.
yeah. If you have a narrow problem, you just can move faster and just deliver some results. So you just now you don't need to think that it's this optimization for analytical load will hurt a lot for LTP load. But in terms of like just kind of purely theoretical, I think it's possible. I don't think there is too much.
And again, I think you're right that it's a question of performance hacking. If your transactional database is not operating at its limit, it's not loaded 100%, probably it can work as some not very efficient analytical system, and vice versa. You can try to use analytical system if it's not really loaded. But when you push the limits, there are a certain point of optimizations, and they are somewhat contradictory.
Yeah.
Okay, so that was very insightful conversation. Maybe you'd like to add something or ask our viewers something. Or...
Basically, thank you for hosting me. That was a nice conversation.
Okay, thank you very much, Stas.
Yeah.